All right, so last time we did the disc and washer method. And with the disc and washer method, the slices that we did in order to be able to do our rotations were always perpendicular to the axis of rotation, right? When we do the shell method, with the shell method, cylindrical shell method, what we end up doing actually is rotating parallel. So our cross-sectional slice is going to be parallel to the axis of rotation. And that will help us be able to determine our variable of integration. So if we're doing, well, you'll see right now when I do this example. So with the shell method, we need a couple of things. So we're going to need to know the height. We're going to need to know the circumference. We're going to need to know the thickness, and I'll explain that to you guys in just a bit, of what's being rotated, okay? So in this first example that I'm going to do for you, we have our x and y axis, and we have these two functions, right? So my first line that I'm going to do is the x plus y is equal to 3. So that's going to go here and here. And the line is going to do this. Okay, so that's the line y is equal to negative x plus 3. Or if you leave it in standard form, x plus y is equal to 3. Our next function is going to be the 3 plus 2x minus x squared. And that right there is going to have at 3 a value, at 0, 3. It's going to cross the y-axis, or the x-axis, I'm sorry, at 3, 0. And then our parabola is going to do something like this. Okay? And if you want, if I'm doing that too fast for anybody, I'll show how to graph that guy. So if you have 3 plus 2x minus x squared, we know that the vertex is found at negative b over 2a. So then what that's going to give us is negative 2 over 2 times a negative 1, which is going to give us a negative 2 over negative 2, which occurs at 1. So when I plug 1 into this, I'm going to get a value of 4. And so the vertex occurs here at 1, 4. Are you guys okay with that? Okay, cool. Just making sure. I know sometimes people can kind of go fast on this, and I don't want you guys to get confused. Okay, so now the axis of rotation for this thing is going to occur at the y-axis. So I'm rotating this thing about the y-axis, right? And the reason I know that is because it says that the region is bounded by the given curves about the y-axis. So that's where we're rotating this thing. Okay? So when I go to do my cross-sectional slice, like I said with the cylindrical method, it's going to be parallel. So is it going to be a vertical or a horizontal slice? What do you guys think? Parallel to the axis of rotation. Well, the y-axis is a vertical line, and so we should have a vertical slice, right? And with the vertical slice here, since we have that vertical slice, we're going to think of how thick this line is as our dx. So that's going to be the thickness of how things are being rotated around. So that's going to be my dx. Okay? The circumference is always going to be 2 pi, and then how far the radius is, right? So what would my radius be here at that cross-sectional slice? And remember, the cross-sectional slice can slide. So the radius of that thing is going to simply be some x value. We don't know what it is because we're going to be somewhere between 0, right? 0 and 3. Okay? And then the height of this red line, isn't that going to be the top function minus the bottom function? So shouldn't that be 3 plus 2x minus x squared, and then plus x minus 3? Are there any questions on how I got those 3 values? Please let me know. Nobody? Okay, so now what we're seeing is that red slice is going to be rotating, and so if I were to draw that, just so you guys could see, it would look something like this. And what's happening is it's being rotated around, right? And when it rotates around, what it's doing is it's forming a cylinder. Do you guys see that? And then there's a bunch of cylinders that are being created. So there's cylinder within cylinder within cylinder. It's like one of those toys where there's like, you take the top off and you pull out the inside piece and it's a cylinder. And then you pull out the next one and it's another cylinder, right? Have you guys seen those toys before? So you can look it up, and maybe I'll try to see if I can find one and share it with you guys at the end of class after I've stopped recording. But there ends up being stacks of cylinders. So let's say that there was another slice here. So if that was the slice there, that would be right here. And then this thing, what it would do is form another cylinder, right? Bear with my drawings. Do you guys see how the orange cylinder is bigger than the red cylinder? And so the red cylinder is inside of it, and so you can see it's following the curve of that blue line. Yeah. So what's happening there is there's just a bunch of them, and then it's following that blue curve with the y equals negative x plus 3. And so we have a bunch of cylinders, and hence, because we have a bunch of cylinders, we have what's called the cylindrical shell method. All right, now, I told you that the bounds were from 0 to 3. So what's going to end up happening now is I'm going to go 2 pi, and I'll put the circumference piece that's just a constant outside of the integral. So I'm going to go 2 pi from 0 to 3. And then I'm going to have x, because that was part of the circumference piece, right? It was 2 pi x. And then the height. So the height is going to be, the 3's are going to cancel. I'm going to get 3x minus x squared dx. Right? And I'll try to do it in color so you guys can see. This is the circumference. This ends up being the height. And this is the thickness. Okay? And then the integral, what the integral is going to do is, what we have here is areas. When we rotate it, we're going to get our volume. And so by doing the, I'm going to do the integral for you guys. It's going to be 2 pi from 0 to 3 of 3x squared minus x cubed dx. So I'm going to get 3x cubed over 3 minus x to the 4th over 4. That whole thing times 2 pi, evaluated from 0 to 3. Well, if we plug in 0, we know it's going to be 0. So if we plug in 3, I'm going to get 2 pi. The 3's will cancel, so I'm going to get 27 minus, is that 81 over 4? And so that's going to give me 54 pi minus 81 pi over 2. And then I can clean that up. So that should clean up to be, is that 27 pi over 2? And then we need to be in units cubed. Okay? Are there any questions on that process? The hard part with these problems is finding the circumference and remembering that you have a radius that you need to multiply by. No questions? You guys are just kind of trying to take it in right now?
I actually have a question.
Sure.
So for the circumference and the thickness, it'll always be 2 pi x and dx or dy?
So no. So the circumference is going to depend on where my slice is going to be taken to dictate whether it's x or potentially y. It could be like x minus 4. We'll do some examples where it's not going to be just x. And the dx for the thickness will always be the variable of integration.
Okay. All right, cool.
And the slice will dictate that for us.
Yeah. Okay. All right. Thank you.
Yeah. It's the circumference piece that's going to be the part that's challenging. And so I'm going to try to do problems for you guys today where you'll see the whole gambit of it. Okay?
All right, for sure. Thank you.
Yeah, no problem. All right. So we did this problem last time. And I talked about if we did it with dx or dy, it didn't matter. So I'm going to show you guys this problem this time. But I'm going to do it with the shell method. So 0, 0, 1, 1, 2, 8. That's this curve, right? That is the y equals x cubed piece. Then we also have x is equal to 0. That's a vertical line that goes right here. And we have another line that goes right here, right? And so our bounded region is, let's see if I can do this a little bit smaller. Our bounded region is going to be this piece right here, right? Agreed? Now, the axis of rotation for this one, it says it's about the x-axis, so now we're rotating this way. Okay? And since we're rotating about the x-axis is a horizontal, and so that tells us that we have to have a horizontal slice. So our slice here is going to be somewhere this way. We okay? Okay. So then, since we're doing it with a horizontal slice, what's the variable that we're going to have? What do you guys think? It's a dy. Very good. So since our thickness or our integration is going to be in terms of dy, that's the thickness of our slice that we're going to have, correct? The circumference of this thing is then going to be found this way. If the x-axis is the axis of rotation, how far is it to this slice? Now, one of the things that confuses a lot of people with this, and it's important for you guys to pay attention to this and understand, where I drew that red slice is irrelevant. It can be anywhere in that shaded region, right? And since the radius can be anything in that area, it's going to be anything from 0 to 8. But since I don't know what number it is, I need it to be a variable, right? And what variable can I use for that? Shouldn't it be y? Right? Because since I'm rotating at 0, right, the y-axis is 0, anything that I move it up from 0 to 8 has to just be y radius. Right? Then the height of this thing now is this on a side. And since it's on a side, we need to know what the height is in terms of y. So isn't that just going to be the y equals x cubed? But since it's y equals x cubed, I'm going to write it in terms of y. So it's going to be the cube root of y. The circumference, so the circumference, this is important. Circumference of a circle is always 2 pi times the radius. That's the formula. So the 2 pi is always going to be there when we're doing the shell method. Okay? When we're doing the disc and washer method, it's the area of the circle. And so the area of the circle was pi r squared. And that's why we always multiply by only pi. Okay, so then from here, what's our bounds in terms of y? So what's the smallest value for y in that shaded region, and what's the highest value of y in that shaded region? Yes, Miranda, it is from 0 to 8. So our integral is going to go from 0 to 8. And instead of writing it outside, I'm going to write it inside this time just so you guys can see. It's going to be the circumference times the height times the thickness. Okay? And then when I rewrite it, 0 to 8, I'll put the 2 pi out. I'm going to write it as y times y to the 1/3 dy. So that way my integral ends up being something very easy and manageable. It's going to be y to the 4/3 dy. So when I take the integral of that, I'm going to get y to the 7/3, so it'll be 3/7 times the 2 pi, evaluated from 0 to 8. Now, that is going to be 6 pi over 7 times 8 is the same as 2 to the 3rd, right? Times 7 to the 3rd minus 0. So the 3's are going to cancel, so I'm going to get 6 pi to the 7th times 2 to the 7th power. And 2 to the 7th power is... what the heck is that? Is that 128? I believe that's 128. So I'm going to go 6 pi times 7 times 128. And that's going to give me, so that's a big number. 768 pi over 7. And then it's units cubed. Oops, I don't know why that deleted that. It's strange. Is it making sense? Okay, good. Now, of course, the radius isn't always going to be X or Y, and so I've got to mess with you, right? Because I want you guys to be able to see problems where the radius isn't going to just be, oh, it's whatever the axis of rotation is. So let's play with one where it's a little bit different. And then we'll play with another one and go from there, okay? All right. So this one's going to be a little funkier. And so because it's a little bit funky, I'm going to need you guys to pay attention. So here's the x-axis. Here's the y-axis. And so what we're going to get is let me go in increments of 2. So y is equal to x squared. So this would be 1, 1. This would be 0, 0. This would be negative 1, 1. And so this parabola is going to look something like this. Right? And I'm not trying to be accurate on the other pieces. I'm just trying to be accurate within these 2 points. And then the next one that we have is at 2. And I should do that in a different color. So 2, and then conveniently enough, this one's going to look like this. So then what our shaded region is this piece right here. Right? And the axis of rotation is going to be along x equals 1. So this is the axis of rotation. And so my slice, is it vertical or horizontal? What kind of slice do you guys think this is? Is it a vertical slice or a horizontal slice? Yeah, it's going to be a vertical slice. That's perfect. Now, one of the things I want to stress, because you're probably asking, why the heck is this guy showing us this shell method when the washer method or the disc method work, right? It should be a question you're asking. And the reason is, if we look at this one, if we were to try to do the the washer or the disc method on this, and this would obviously be a washer method problem if we were trying to do it that way, can we do it? Look what happens. If I were to, and I want to do it some bold, if I were to do a slice that's horizontal, right? Is that purple line hitting the same function? Yeah, since it hits the same function, we can't have that. Because the height of the function would be the function minus the function, which would always give us 0. So in this problem here, it's impossible. Well, I don't want to say it's impossible, but it's not as easy for us to use the washer method. And so we need to use the shell method. It's just going to be easier. Does that make sense? And that's why this method has been brought about. So we have to go parallel to it. And so we end up with our 3 things that we need, right? We need our height, we need our circumference, and we need our thickness. And so the thickness tells us the variable that we're integrating with. And so we're going to be integrating in terms of dx, correct? Because that vertical slice is going to eventually cross the x-axis. And so that tells us that it has to be a dx method to do this problem. We okay? All right, so it's dx. So, and the axis of rotation is at that x equals 1, so I want to stress that. So tell me, what is the radius? And this is where we're probably going to have a conversation for a while. What do you guys think the radius is? I'll do the hard part. 2 pi, what's the radius? It's crickets. Very close. X squared? No. Any other guesses? X? No, not X. So think of it this way. So if the red line is my axis of rotation, if I was here, wouldn't that be 1? What would it be here? I'm sorry, wouldn't that be a half? Wouldn't that be 1? What about right here? Wouldn't this be 1.5? And then right here, wouldn't it be 2? Right? Because if this is the axis of rotation, to get way out here, wouldn't that give me a radius of 2? But the thing that's crazy is since I'm to the right of the function, if my slice is here, isn't it going to be 1 minus x? But then if I'm here, it all of a sudden would add the x, right? So it'd be 1 minus, but since we're in the negative realm, that's okay. That makes us get that extra distance. So it'd be 1 minus a negative half, which would give us a radius of 1.5. So what ends up happening is the radius ends up being 1 minus x. And I know you guys are all like, what? But that's the thing about this that gets so tricky. Setting these up, you have to be very, very, very careful about finding the radius. Does that make sense? Does anyone have any questions so I can clarify? Sure. So, looking at it from this perspective, if I'm here on this red line, right, that's where everything is being rotated about, right? So this point right here would rotate and go like this around, right? This red line would go and rotate this way around. A point here is going to be smaller than a point out here, right? So then what ends up happening is the distance, though, this is x equals 1. So automatically, what we end up having is that's going to be 1 to the y-axis, right? But since our slice can be anywhere in that shaded region, if let's say we call it x, right? So if x is right here, that would be like a half, right? So the half that's being stated right here is from the origin going to the right. But I'm not rotating from the origin, I'm rotating from this line. And so if I was at a point right here, it'd be 1, because that's where we're at, minus a half, which would put us right here, and then that would be the rotation. But if I was over here, now isn't that a negative 1/2? So now the rotation from here to here is 1, but I've got to go an extra half. But that's a negative number. So that means I've got to go 1 minus a negative half to get that radius, which is 1.5. So let me do it with numbers for you guys, okay? So I said this was a half, right? My radius is the pivot point of that red line. So I'm going to go 1 minus a half gives me a radius of a half, correct? You guys agree that if I'm here, the radius to the red line is only a half distance away, correct? Okay, cool. But if I'm at a negative a half, that has to be 1.5 distance. So if I'm over here, I'm going 1 plus a half to get my rotation. Yes. Does that make sense? And so once I end up in the negative realm, I'm always going to be, when I subtract a negative, it's going to add it. Does that make sense? Rule of thumb, Julian, just so you know, if you're going to be right of the shaded region, it's typically going to be that number where you're rotating by minus the variable for rotation. Yeah, so if we were going to do that at 3, it would have been 3 minus x. If I would have been on the other side, let's say I would have been at a negative 3, then it would have been, then it changes our problem just a little bit there too, which we're going to do all those in just a bit, don't worry. I'm going to set them up so you guys can find the radius. But I wanted you guys to understand what's happening. You guys feel like you're starting to get it? Okay. Cool. All right. So then the height of this thing, though, is going to be the blue curve over the black curve. And the blue curve was 2 minus x squared minus the black curve, which was x squared. Now, the intersection bounds in terms of x are from where to where? What do you guys think? What are the bounds? Yes, it's from -1 to 1. Okay, so now I can pull the 2 pi out. I'm going to go from -1 to 1, and I'm going to get 2 minus 2x squared minus 2x minus 2x cubed dx. Are you guys okay with that? Okay, so then when I integrate this, I'm going to go 2 pi 2x minus 2x cubed over 3 minus 2x squared over 2 minus 2x to the 4th over 4, and evaluate it from -1 to 1. And that's going to give me 2 pi 2 minus 2/3 minus 1 plus a half minus a -2 plus 2/3 minus 1 plus a half and that should give me 5/6 minus 11/6 that will give me let me see, am I right? I think this is a negative 6, 11/6, right? Yeah, it should be negative. So that's making a plus 16, 16 pi over 3, and then units cubed. Yeah, why did that delete? Are we okay? And don't worry, we're going to do more problems where we practice the radius. So don't worry about that. One other thing we need here is y equals 0. I want you to try this one right here, and then I'll do it with you. But I want you guys to try it real quick, please. See if you guys can come up with what it's going to be, and then I'll do it with you guys using this shell method. Okay? I'll give you guys a few minutes. Did you guys get that graph? Quick question for you. What's the region? Is it to the right or to the left of the y-axis? Is it both? It's to the right. Very good. Vertical or horizontal slice? Okay, that's right. Excuse me. Are you guys ready for me, or do you want me to wait? Okay. All right, so what's the thickness then? That's right, it's going to be dx. Let's do the next easiest piece. What's the height? Remember, the height's the piece that's the cross-sectional slice, the piece in red, what it should be. Y plus 2. So we're looking for how tall this is, right? What's its height? So if we look, it's following this curve, right? So the cross-sectional slice falls on that curve. So what is that curve? Doesn't matter where I do it, I'm always going to hit a height on that curve. Right? And so if it's going to always hit that curve, what is that curve? You almost had it, Julian. It's 1/4 x squared. Yep, that's it. So the height is 1/4 x squared. Now, I'll do the hard part for the circumference. It's 2 pi. What is the radius? What do you guys think the radius is? Now, I'll give you a cool hint with these so you never have to think. If you're rotating along the y-axis and it's a shell method, the radius is always going to be x. If you're rotating along the x-axis, it's always going to be y. So in this case, my radius is going to be x. Are we okay with that? So now that we have that piece, we can set this integral up. And so it's going to be, the volume is going to be 2 pi the integral from where to where? This is 0, this, oh, I'm sorry. That's 1, this is 2. That's 0. So we're going to go from 0 to 2. Very good. X, and then the height, right, which is 1/4 x squared dx. So before we integrate, we should get 1/2 pi integral from 0 to 2 of x cubed dx, which will give us x to the 4th over 4 times 1 over 2 pi from 0 to 2. Oh, that's cute. We're going to get pi over 2 times, what is that, 4? So my answer is going to be 2 pi units cubed. We all right? Okay, now I want to be able to check this problem. So I want to do it with the washer method just to make sure that I'm getting the right answer. Okay, so I'm going to do that same problem, but I'm going to use the washer method. And again, we're rotating about the y equals, or x equals 0, or the y-axis. Now we need to do a cross-sectional slice that is perpendicular, right? If we're going to do the washer method, and this is just doing the washer method to confirm that we're getting the right answer. Okay? So, just in case you guys don't remember, it's the integral, we have our pi, and it's the outer radius squared minus the inner radius squared, and those whole thing times our du, whatever the variable is that we're using. Correct? Okay. Now, this here then, the outer radius, this would be 2, right? So the outer radius for this guy is going to be, the integral is going to go from pi from 0 to 1, and that's because we're doing it in terms of dy, because we're going to cross the y-axis, correct? And then the outer radius is going to be that 2 squared minus the inner radius, and this function here in terms of y would be, remember it was y is equal to 1/4 x squared, and since it's that, I'm going to get 4y is equal to x squared, so then 2 radical y is my x, right? So then the height of that thing, or I'm sorry, the inner radius is going to be 2 square root of y that quantity squared. Do you guys agree with that? We okay? Okay, so then I'm going to get pi 0 to 1 of 4 minus 4y dy, which is going to give me 4y minus 4y squared over 2. We valued it from 0 to 1 times pi. That's going to give me pi times 4 minus 2 minus 0, which is going to give me 2 pi units cubed. And I think that's the same answer as what we got prior. Cool. So I did it 2 ways, and I saw that I would get the same answer. Okay? One using the washer, one using the shell. But you can see that, to me, the shell method for this problem is a lot easier, right? There'll be times that you're going to have to look at setting maybe both ways up and see which one's better. Okay? Okay. Now I want to take you on something that I would have done on an exam for you guys, so you guys can understand the process that we would have gone through. Okay? This is what I would have done to you guys on a test. So this is something that you guys should totally try and comprehend and understand. Okay? So if I gave you right, so this is the x-axis, here's the y-axis, and then I gave you, okay, I gave you something like this, right? Oh, that's terrible. Right? Right? So that this would end up being the shaded region. On an exam, what I would have done had we been live in class, I would have done this to you guys. There's an axis of rotation. Here's an axis of rotation. Here's an axis of rotation. And then I would have done something like, I want to keep it all in the picture. Move this. Here's an axis of rotation. That would have been y equals -2. This would have been x equals 4. And then I would have said, all right, guys, I want you to set them up. So there's 4 problems here. I want them all set up. Okay? And this would have been a big chunk of your exam. Not even doing the integration, but can you set them up? So I'm going to do it for you. Which one do you want me to do first? Okay, cool. So I'll do that one, and I'll do it in red because it's red. So that one would be, the integral would go, since we're going that direction, we could do, so what's easier for me to do on that one would be to do the shell method. And the reason the shell method's easier for me, is the shell method easier? No, you know what? It's easier to do the washer method. So the washer method then would be a vertical slice, so it's going to be a dx. And my outer radius would simply be 5 squared minus the inner radius, which would be 5 minus, and I didn't tell you that curve, did I? That curve is y equals x squared. So then that would be 5 minus x squared squared. Are you guys okay with that? Oh, and the bounds, I'm sorry, from 0 to 2. Do you need me to explain how I got it? Oh, the 5 minus x squared. Okay, so remember, with the washer method, it's outer radius. So since this is the axis of rotation, the outer radius is all the way to the furthest point shaded, which is the x-axis. So that means that that's 5 squared. You got that, right? Okay. The inner radius is going to be from here to the inner part of the curve, or to the closest part of the curve. And so that's going to be 5 minus, how high is that? How high is the function? The function's x squared. So it's going to be 5 minus x squared, right? And each one of those radii need to be squared, so that would be the setup for that one. Okay, which one do you want me to do next? The y minus 2? Okay, cool. That was in pink, so I'll do that one. It's pink. So that's going to also be done in the washer method. So the outer radius is going to be 2 plus the function. So that means my outer radius is going to be 2 plus x squared minus the inner radius, which is going to be this distance here, which is simply 2. So then it'll be 2 squared